If you have a computer build that's more than 3 or 4 years old and you want to upgrade something like, say, the graphics card, but you don't want to build an entirely new system, what kind of performance might you be leaving on the table if you simply upgrade the GPU? Let's find out. Hey there, welcome to the channel. I'm Danny, and for today's testing, I'm really just strictly looking at the gaming performance comparison. Since this is a gaming-focused channel and all, but remember, workstation performance scales with these comparisons as well, so keep that in mind. The new GPU I chose for this test is the ASUS TUF Gaming RTX 3060 OC Edition. It has 3,584 CUDA cores, 12 gigabytes of GDDR6 memory running at 15 gigabits per second on a 192-bit bus. Now, ASUS recommends a 750 watt power supply for this GPU, but to me that's kind of silly because the PCIe connector can only output 150 watts, and the board power that can come out of the motherboard is only 75 watts. I think these companies are going a little over the top now. Now, you can go into ASUS's website and actually they have a power supply prediction generator or whatever. You put in your CPU and your GPU that you want to choose, and then you say if you're going to overclock or not overclock. And obviously, if you select that you're not going to be overclocking, which most people don't do anyways, it recommends a little bit lower wattage than what they recommend from the card's specs page. But that power requirement doesn't even matter in our test bench here. It might not look like much, but let me show you some of the parts it has. As I said, the power supply is pretty beefy. It's a Corsair RM850x 80 plus gold rated with plenty of power to handle any GPU I decide to throw in here. The motherboard is an MSI MAG B550M Mortar Wi-Fi. It's the B550 chipset with all the good VRM cooling, and it can handle any current AMD Ryzen CPU. The storage is a Samsung 980 Pro NVMe SSD. It's 1 terabyte. This is a very fast PCIe Gen 4 drive with plenty of storage for games. For the RAM, I chose G.Skill's Trident Z 16 gigabyte kit running at 3200 megahertz. To cool the CPU, I have a Corsair H115i Pro RGB liquid cooler. It's a 280 millimeter radiator providing a nice cooling solution for any CPU I might want to run in this test bench. Finally, the test bench's build is inside of the Fractal Design Meshify 2 Compact. This is really just the skeleton of the case. You can see I don't have anything on the top here. That's because this top panel can be removed with 2 screws, and I took all the filters and everything out of it as well, just so I have an open air test bench and I don't have to spend a ton of money. I did a little bit of modification, as you can see from the front of this. I actually mounted the radiator to the front panel and then put the fans on the outside of the case mounted to the very, very front of the panel. With the fan set up the way Fractal wants this to be, you can't fit a long GPU in here that's bigger than probably this TUF gaming card. So now with the way I have it laid out this way, I can fit anything in here, even the ASUS ROG Strix cards. Why don't we talk about the CPUs that I decided to use in this testing? The CPUs I used are the Ryzen 5 5600X, 6 cores and 12 threads, boosting up to 4.6 gigahertz. It's got 32 megabytes of L3 cache, and it's built on the 7nm FinFET process node. This CPU came out in November of 2020. The second CPU in testing is the Ryzen 5 3600. This is also 6 cores and 12 threads, but only boosts up to 4.2 gigahertz. It's got 32 megabytes of L3 cache as well, and it's built on the 7nm node also. This CPU came out in July of 2019. And then of course, I had to throw in something fairly old to see what the scaling would be. The third CPU is the Ryzen 5 2600X. This is 6 cores and 12 threads and boosts up to 4.2 gigahertz, just like the 3600. However, it only has 16 megabytes of L3 cache and is built on the 12nm FinFET process. This CPU came out in April of 2018. Now, I ran 4 different games for these benchmarks. They were all at 1080p, ran on max settings as well. These are the average frame rate results of 3 runs each using the same RTX 3060. Also, feel free to pause the video at any time if you want to take a closer look at any of the charts. The first game I tested was Forza Horizon 5. For the 5600X, I got 88 FPS. Well, the 3600 was pretty much the exact same thing. It was 88.4 over the 3 runs. Now, the 2600X starts to show its age a little bit at 76 FPS. The second game tested was Rainbow Six Siege. The 5600X achieved 224 FPS average, the 3600 achieved 223.4 FPS average, and the 2600 obviously jumped down a little bit at 214.4. Once again, the 2600X is starting to show its age, but the two 3600 and 5600X are really right on par with each other as far as gaming performance goes. The next game up was Apex Legends. The 5600X achieved 152.2 FPS average, the 3600 achieved 157.9, and the 2600X achieved 139. Now, you can chalk the 3600 up to beating the 5600X just by variance between games. So that's me actually playing the game. The 3600 gets pretty much the exact same frame rate as the 5600X again. The last game tested was Shadow of the Tomb Raider. This is really interesting to me because it scaled really well with each CPU jump. The 5600X achieved 117.6 FPS average, the 3600 came down to 108.8, and the 2600X achieved 84. This is the only game that had perfect scaling with each CPU upgrade. So this is a perfect example of the 5600X's increased performance over the 3600 and the 2600X. As you can see, running an RTX 3060 at max settings, even on 1080p, is still bottlenecked by the GPU. So you'd be just fine running any CPU from the last 3 or 4 years. Now, if you go over 4 years with something like a 2600X, you'll start to see a drop in performance as we saw in the charts. Of course, there are many factors to consider when picking a CPU, such as IPC, core counts, and clock speed, to name a few. These factors will cause differences in generations on more than just average FPS numbers. Now, I didn't include the 1% and 0.1% lows, but just know as you go back generations, those numbers get worse and worse. A more modern CPU like the 5600X can also give you an improved desktop user experience too, and that's not even talking about workstation performance increases. My bottom line is you can run an older CPU with a newer GPU, such as an NVIDIA 30 series card or AMD 6000 series card. But, little asterisks, I would say save up the extra money and just build yourself an entirely new system to take full advantage of the next gen hardware that you've just purchased for your graphics card. If you want to know what CPUs you should be pairing with which GPUs, you might want to check out these videos over here next. And as I always say, I'm Danny with Danny's Tech Channel, and I'll see you in the next one.